In example 1, we need to find the area of triangle ABC. If A is 4.7, C is 12.4, those are both in meters, and the measure of angle A is 17 degrees. While not totally necessary, I do like to try to draw the triangle itself so we can see what's happening. Let's make this A here. A will be 4.7 then. We know the unit is meters, we'll keep that in mind. And that's A then. And then let's do, well, let's just go B here and C. This is kind of longer and C is going to be longer, so let's do 12.4. And we don't know B here. And A was 17 degrees. Alright, to use one of the formulas with sine in it, we would need to know this angle B. We need to know the included angle between two sides. We could also try to find side B, and that would give us these two right here. Either way would work, really doesn't matter, but I think it's probably going to be easier for us if we try to find, let's see, maybe angle C, and then we could find angle B pretty quickly. So let's see if we can do that. We'll have the sine of C over its opposite side, and this is the law of sines here, is equal to the sine of angle A, which is 17, over 4.7. Solving for C, we'd multiply by 12.4 on each side. Sine of C is equal to then 12.4. We usually write this number out in front. Sine of 17 degrees so that it doesn't get confused with the 17 degrees. And that's over 4.7. Remember, when you're looking for an angle, you need to use the inverse sine. So we'll do that here in our calculator. And then it'll be 12.4 sine, that's the regular sine of an angle, and then divided by 4.7. I also, before I hit enter here, I like to make sure I'm in the correct mode, so I'm in degree mode here, and we are using degrees, so we're good to go. That gives us an angle of about 50.5. We'll round to the nearest tenth here. So that's 50.5 degrees. We can now easily figure out B. We could just do 180 minus 17 minus, we'll just do our answer for grins. You could do 50.5 as well. And it'd be 112.5. So now we've done a little legwork. We found some missing values that will help us. And we can now set up the area as being 1/2. In this case it's A and C. So this will be AC sine of B. We'll take 1/2, multiply it by A, which is 4.7, 12.4 for C, and then the included angle. If you want to think about that, that's okay too. Just take two sides and the included angle, and you'll fill those in the formula. We can now type that in the calculator. So we'll do 1/2 times 4.7 times, oops, hit the 4 there a little prematurely, 2.4, and then sine of 112.5. That gives us an area of about 5.2. And you know what, I don't think that's making sense right now. It seems like it's a little low. So I'm going to go back to my formula, and yep, I just caught it right there. Did you see it? I'll put this in. Forgot to put in that 12 right there. I just did 2.4. So it's always a good idea to just check the reasonableness of your answer. I mean, if this side's 12.4, that's 4.7. Seems like we're probably going to be somewhere in the 20 to 30 range, something like that. Imagine if this altitude here, we could guess and make that maybe maybe that's 2 or something. That would make sense in this case. So or maybe like 3, somewhere in there. So we'd have 1/2 times 12.4, which is 6, times 3, which is 18. So it's going to be somewhere way north of 5. And it looks like we're going to be at 26.9. So the area here for this one will be 26.9. We're given meters, so we're going to write meters squared. This makes better sense, I think, in the context of the problem. That's a more appropriate answer. So just be aware that you might make an error in the calculator. Always check the reasonableness of your answer, and that can really help you find those calculator errors that you might have typed something wrong in, or perhaps a negative sign.